All right, this should be the last video about parallel and perpendicular lines. We're on page 43. This is actually writing equations of parallel and perpendicular lines. So if you look on page 43, you'll see exactly what we're talking about. All right, so the topic is right here, writing parallel and perpendicular equations. Now, remember, parallel lines have the same slope. It's all about the slope. And perpendicular lines have negative, I'll abbreviate it, negative, I'm going to abbreviate this too, because these are long words, negative reciprocals of each other. In other words, flip and switch. Flip and switch, okay? Sounds like the name of a fast food restaurant. All right, so same slope as parallel, negative reciprocals, that's perpendicular. Now, there are two things that you're going to need to be able to remember. All right. The first is you're going to need the point slope formula. You're going to use that a lot. So you might as well write it right here. You're going to need to use that. The point slope formula. That's going to be important. And also important is y equals mx plus b. This is the form your answers are going to be in. You're going to use this and you're going to end up, your answer is going to end up looking like this, but you're going to use the point slope formula. Okay, so let's look at, let's do a parallel example. All right, so we're going to write the equation of the line that passes through negative 2, 7 that is parallel to this line right here. Now, you might want to go on Desmos and graph that line, but negative 4x plus 1 looks something like this. It's a very steep line in the negative direction. It goes through 1 on the y-axis. Now, the point negative 2, 7 is about, it's about right here, and we want to find the line that's parallel to that goes through that point. Now, we're going to start with y minus y1 equals m times x minus x1. Remember where you put checks. You put checks here, here, and here. That's where you're going to fill in numbers. Now, we see we're going to plug in for x1 and y1. That's this right here. But what do we plug in for m? Now, these are parallel. What do you know about parallel? Parallel has to have the same slope. What is the slope of this line? The slope of this line is negative 4. Now, do we care about the y-intercept? No, we don't. I don't care about that y-intercept at all. The only thing I care about this line is the slope. I want my line to be parallel to this line. So the only thing I care about is the slope. So the slope I'm going to use is negative 4. Now we're ready to plug everything in. All right, so we're going to plug in 7 for the y1. The slope we're going to use is negative 4. And it's going to be x minus, we're plugging in a negative. That's going to wrap. Now, some of you can skip the wrap step. You know the wrap step. When you plug in a negative, it's going to turn into a positive anyway. You know that. So that's going to be negative 4, x plus 2. Now, to get that in slope-intercept form, in other words, y by itself, you need to distribute. And you're going to add 7 to both sides. So negative 4x minus 8, add 7 to both sides. You're going to get y equals negative 7x. Negative 8 plus 7 is negative 1. Wait a minute. It's negative 4. I'm sorry. Negative 4x minus 1. That's what negative 8 plus 7 is negative 1. All right. Now, number 2, what is the slope of that line? We want parallel, so it needs to be the same slope. You can't tell what that slope is yet. You have to get y by itself first, all right? Which means you need to move the x over. And then you're going to divide everything by negative 3. All right? Those cancel. Now, what's in front of the x, even though you can't see it? It's a negative 1. And a negative 1 divided by negative 3 is a positive 1/3. Now, I know the y-intercept is negative 3, but remember, I don't care about that y-intercept. The only thing I care about is the slope. My line needs to be parallel to this line, which means it needs to have the same slope. So now you're ready to plug everything in. What are you going to use for x1, y1? You're going to use the point they gave you. All right. So that you're going to use 3 for the x1, -1 for the y1. What are you going to use for the slope? You're going to use 1/3. So you're going to go y. Now that's a double negative. That's going to be y minus -1. That turns into a +1. What are you going to use for the slope? 1/3. It's going to be x minus 3. Now I'll let you finish that. You're going to have to distribute the 1/3. That's a +1. So you can end up subtracting 1 from both sides. I'm going to let you finish that. I don't need to finish that. I've set it up. You know what to do next. Now let's look at 2 perpendicular examples. Now what does this look like? Well, this line, 2x minus 4, looks something like this. If you were to graph it on Desmos, it would have a y-intercept of -4 and the slope is up 2/1. Where's the 0.43? The 0.43 is about right there, and it needs to be perpendicular. So I'm trying to find the equation of this line right here. All right, that's perpendicular. It intersects at a right angle. All right, now this is the point. This line, I do not care about the y-intercept. The only thing I care about is the slope. The slope of that line is 2, but we don't want that slope. We want the perpendicular slope. What slope is perpendicular to that? The slope that we want, the perpendicular, remember that's the slope for perpendicular. The perpendicular slope, we have to flip and switch. How do you flip and switch? We'll put a 1 under it. You flip it and switch the sign. So that's what you're going to use for m, okay? So you're going to put y minus y1 equals m times x minus x1. Remember, check, check, check. What do you put in the place of y1? You're going to put 3. What are you going to put in the place of m? -1/2. The flip and switch of 2. And that's going to be, what are you going to put for x1? You're going to put 4. All right. Now, if you distribute, -1/2 times x is just -1/2 x. Now, if you need a calculator, -1/2 times -4 is +2. You're going to add 3 to both sides. And my final answer is -1/2 x plus 5. Now, how can you check your work? You can check your work by graphing that and the original equation on Desmos. Make sure that it look perpendicular, and does this line pass through this point? You can check that. Now, number 4, the last example we're going to do, it needs to be perpendicular, but we don't know the slope of that line yet. Y is not by itself. We got to get y by itself, so move the 5x over. That's a 21. That's a +21. That's a smudge, I think. Remember, I don't care about the y-intercept anyway. All right, divide by 3, divide by 3, divide by 3, divide everything by 3. That's -5/3 x plus 7. Now, what is the slope of that line? -5/3. I don't care about the y-intercept. So the slope is -5/3. But remember, this is perpendicular. I don't want that slope. The perpendicular slope is flip and switch. Flip it over, switch the sign. So it switches from negative to positive. Now you're ready to use the point slope formula. What are you going to plug in? This is your x1 and your y1. So you're going to plug in 1. You're going to plug in 3/5 for m, and that's going to be x minus -5. That's going to become x plus 5. Your next step should be to change that to x plus 5. Now, I'm going to let you finish that. I don't need to finish that. You're going to distribute, and then you're going to add 1 to both sides.